Hello. So it's finally Friday, so we are going to do only two questions today. It says a truck driver traveled 300 miles in 8 hours. If the trucker averaged 65 miles per hour, which linear equation could be used to find the number of hours that the trucker drove? So if we look, it says he traveled 300 miles. So we know that that is our total. Okay, so if we look over here, everything is still the same, so we can't cross out anything. It says in 8 hours. So it says if the trucker averaged 65 miles per hour, which means 65 times hours, which linear equation could be used to find the number of hours? So we look here, 300 equals 65 plus hours. Nope, that's not going to be able to find the number of hours that we drove. So A is not correct because remember, it's 65 miles per hour. So 65 times hours. Now we have 300 equals 65 minus H. Nope, that still doesn't quite work. And now we have 300 equals 65 times H. Yes, because it is miles per hour. So it is 65 times something hours to figure out our total of 300 miles. Okay, now it says which statement best describes the following linear equations? X equals 3 and y equals 3. So first we can think of it as in a graphing sense. Now some of us might not be able to remember, which is okay. But if we graph these, we have x equals 3. So when we have x equals something, that means we're going to be able to figure out all of our x values. All of our x values. So our y values are actually going to be the ones that are going to be changing. So if we look here, if our x-axis is here, and we have x equals 3, we know that our x value stays the same at 3. So therefore, our equation of x equals 3 would look like this, just a vertical line. Now if we look at y equals 3, all of our y values are going to be 3, but therefore our x values can change. So if we think of it like this is actually the line of y equals 3. This one right here. If we look, do the lines have the same x-intercept? No, not quite. And now it says lines are parallel. Do we think that these two lines are parallel? No, they should be something else. They should look like something else. It says lines have the same y-intercept. Not quite, because this y value will be able to change on here, but it can't change on there. And lastly, we have lines are perpendicular. Can we agree that these lines are perpendicular because they can form a right angle right there? So yes, we can. These lines are perpendicular.